Welcome students, and our next video is on mean. Mean for an ungrouped frequency distribution. As we already know, mean for an ungrouped frequency data, we can calculate it using three different formulas. The first one is our direct method, second one is assumed mean method, and the third one is step deviation method. So now we will see one by one the formula. The first method, direct method. Direct method, the formula is given as mean is equals to sigma fi xi by sigma fi. Our second method is assumed mean method, where mean is given as a, that is assumed mean, plus sigma fi di by sigma fi, where di is deviation. Deviation means it is deviation, the x is deviated from the a or the assumed mean, which is given as di is equals to xi minus a. And our third method is step deviation method, where mean is given as a plus h multiplied with sigma fi ui upon sigma fi, where a is the assumed mean, h is equals to x2 minus x1, and ui is equals to xi minus a upon h. So today we will discuss upon the second method, that is assumed mean method, and we will go with one example. So let us see one example with assumed mean method. Here you can see the weekly wage and number of workers is given in a tabulation form. It is the frequency distribution table. So weekly wage of the workers are given 950, 1000, 1050, 1100, 1250, 1500, 1600, and numbers of workers is given accordingly. Here we have to calculate the weekly mean wage. By which method? By assumed mean method. So the first step is to make the tabulation with weekly wages, which is taken as xi, and the number of workers, which we take as fi. Number of workers is the frequency. As we know, the formula for assumed mean method is a assumed mean plus sigma fi di by sigma fi. So first of all we have to see the assumed mean. What is assumed mean? We have to assume among the weekly wages 950, 1000, 1050, among these wages one we will take as mean. We will assume that this will be the mean of the following distribution. So here we take the mid value, that is 1100, as the assumed mean. We assume that among this distribution 1100 is the mean. That is not the exact mean, but we are assuming. The next step is to find di. From the formula you can see sigma fi di. We have fi, but di is not there. So we have to find or make a column of di. Di is equals to xi minus assumed mean. So xi minus 900. 900 is our, 1100 is our assumed mean. So as you can see, di column 950 minus assumed mean, that is 1100. We get minus 150. Similarly, the second row we have 1000 minus 1100. We get minus 100. Similarly, the third one 1050 minus 1100, we get minus 50. So accordingly we will complete the column of di. So after completing the di column, we will next move on to the next column, that is fi di. You can see the formula sigma fi di. So we need to have one more column fi di. So here fi we take 24 multiplied with 150 minus 150. Then again 18 multiplied with minus 100, that we get minus 1800. Similarly we will continue 13 multiplied with minus 50. We get is minus 650, and 15 multiplied with 0 we get 0, 20 multiplied with 100 we get 3000, and we'll complete the column of FIDI. After that we will put the formula, we'll write the formula and put the values to get the mean. So now you can see that we have taken out sigma Fi. Sigma Fi is equals to, you can see the F1 column, 24 plus 18 plus 13 plus 15 plus 20 plus 11 plus 9. We get sigma Fi is equals to 110. Similarly, we have to find out sigma FIDI. You can see FIDI column, we will add minus 3600 minus 1800 minus 650, 0 plus 3000 plus 4400 plus 4500, and we will get sigma FIDI equals to 5850. We will put these values in the formula of mean. Mean is equals to A plus sigma FIDI by sigma Fi, that is equals to, assumed mean value is 1100 plus sigma FIDI 5850 by 110, and after calculation we will get 1153.15, and this is our mean. And this is the complete process, step by step process to find the mean of the following ungrouped frequency distribution using the second method, that is assumed mean method. So I hope students that you have understood the assumed mean method step by step, and you will do good in your examination. Thank you, students.